So let's continue with our insert interval problem. So as I said, this is a bit tricky, and the same logic that we used in our merge interval can't be applied here. Okay, so let's see that in detail. Firstly, let's read the question that we are given an non-overlapping intervals array, right? So whatever is, all the intervals in this intervals array are non-overlapping. Okay, and moreover, they are sorted in ascending order by start, which we did manually in our merge interval problem, which is this one. Okay, and yeah, I have to show the strange thing about this, that as we have seen that our space complexity was O of n, but I have submitted this code few days ago, and if you check space complexity for that, it's giving O of 1. It's the same code, like nothing is being changed. You can pause and see it. Okay, and the thing that we submitted today is this one, and it's also the same. But here, if I check the space complexity, it's getting O of n. Okay, so there is some problem, but anyways, I think it's O of 1 because we are not using any extra space for storing the intervals again, the sorted one, right? We are just taking the extra space to store the previous, the very first interval into previous, which is a constant space, right? So I don't think it's depending on anything. So I think it should be off 1, but anyways, let's continue. So that's a bug of Leetcode, you can say. Or if I miss something, please let me know. It might be that I have overseen something. So anyways, but here the intervals array that's being given is being in sorted order based on its starting index, or you can say start interval. Okay, but the trick is here we are given a new interval, and that's why the name insert interval, that we have to insert this new interval into the existing intervals, okay, such that if there is an overlap, we should merge. So you can see that if there is any overlap, merge the overlapping intervals if necessary. Okay, and then return the array. So at the end, we have to return the array after all the overlaps are merged. Okay, you can see here 1, 3, and 2, 5. We know that there is an overlap. So it will be 1 and 5. So you can see it will be 1 and 5. But then 1 and 5 and 6 and 9, there is no overlap. So we will just return 6 and 9 as it is. Similarly, you can check here that 1, 2, then 3, 5. Okay, but here we have 4, 8. So 1, 2 has nothing to do with 4, 8, no overlap. But with 3, 5, there is, like with 4, 8, right? So we know that 4, 8 overlaps with 3, 5, 6, 7, and 8, 10. And all this will be combined to 3, 10 at the end. And then this has no overlap with anything, so it's as it is. So this is how we have to return. So it's a bit tricky, but I'll explain you. And the same logic, so you might wonder that the same logic of previous problem can be applied, but this can be converted into a previous problem actually. So what we can do is we can simply add this new interval into this existing intervals and sort it. Okay, so it will take n log n, and then the problem becomes the same of merge interval. So we can use the same problem again, right? The only thing is that we have used extra n log n. Okay, although time complexity will be n log n and plus O of n, but higher term matters, it's n log n just for sorting. But here we are already given a sorted array, right, by start. So why to do again the sorting, right? This approach is correct. It will take O of n log n. Can we reduce it somehow? Okay, so, and we will see if we can reduce it. So firstly, let's check and write approach 1, and let's see how that approach 1, the same similar kind of thinking of approach 1 won't work here. Approach 1, like just add new interval into existing one into intervals list, and then sort. So time complexity will be, to sort, will be O of n log n, and plus O of n to iterate and merge everything. So at the end it will be higher term domination, so it will be O of n log n. And I don't think we are using any extra space, so it will be O of 1, the space. So it will be converted into problem number 56 again of merge interval. But can we do better? Okay, and that will be our approach too, which will be an optimal approach. And can we do it in O of n? Maybe. Let's see that. So what we will do is that firstly we have to find its position in this array, and as a human we know that it will be in between, right? 1 5, and then it will be 2 5, and then 6 9, and we know 1 5 2 5 will overlap. So we can say that, oh sorry, this is the answer, sorry, the position will be here 2 5, okay, in between, and we know that 1 3 and 2 5 will overlap, so it will be 1 5 at the end. Okay, so can we use similar logic when what we used in the last problem, which was this one? And we know that what we used here, right, that start of the next interval should be less than or equals to end of the previous interval. Can we use the similar logic here? Let's see that. So what I'm saying is that, can we, if my starting of the new interval is less than or equals to the ending of the previous interval, right, then we can say that these two are overlapping, correct? Same condition, but this is incorrect here. It won't work. Let me show you how. If you, because anyone will think the same after solving that problem of merge interval, everyone will think that okay, this can be the logic, but it will fail here. Why? Let's say we are using the same logic, and we know that we got that there is an overlap. Okay, so I will say that it will be 1 5, and then what I'll say is that it will be 6 9, right? This should be the answer. I'm writing the answer, but after this is being done, okay, let me write it programmatically, that what we are doing is we are checking new interval of 0 if it is less than or equals to my current. In our for loop we will run our current, so let's say it's ith index right now, so we are at 1 3, and we will check the last one, which is 1. So this is what we will check as our logic. So after this condition is satisfied, we are merging it. So let's say with our merge logic that we used in our previous problem, we got 1 5. Now again we will check. We know that 1 5 and 6 9 there is no merge, no overlap, right? So we can't merge them. But with this logic, they will be considered as overlapped. How? Because as I said, in order to merge with the previous logic or in the previous problem's logic, we need to have previous and current, right? Right now this was our current and this was our previous, right? But after this merge is being done, right? But still we are using the same logic, that we are checking the new intervals. So what's the new interval? It is this one, right? We are checking this one. This one's first is less than or equals to this one's last, right? So here still we are considering this as previous, correct? Because previous is the one where we check the last, right? So this will be considered it like this, that we are considering 6 9 and 1 5 is here. So we are just considering whether this is less than this, if we are using the same logic, right? If 1 is less than or equals to 9, and it is, right? It's less than 9. So we will say that okay, this is being merged, and then we are merging it, and at the end we will get 1 and 9, right? Which is incorrect, right? Like, I mean, this is not gonna work, right? So the same logic is not going to work here. If you use the same logic, you will merge everything, which is not merging. So here the correct logic for overlapping should be that we have to interchange the role of our current and previous. Okay, here we have considered this as a current and this as previous, but in the next case we are not switching the roles. Okay, so this should be current, and then whatever we get after the merge, that should be previous, not this one should be previous, which is the current. And that's why this logic is not going to work in our end. What will work, let me write that. So the correct logic will be that rather than checking, let's say my new interval is, was it 2 5, I forgot. Yes, so let's say my new interval is 2 5. Okay, so what we will check is, this is, I'm writing the logic, that new interval of 1. So rather than checking the first index of new interval, we will check the last index. Okay, whether my last index is greater than or equals to my current. So my intervals of, let's say, ith current, and it's 0. So what I'm doing is, let's check with the same logic that 2 5 is the new interval and my current is 1 3. So what I'm checking is, it might sound strange for first iteration that, oh, this is not working, but it will make sense if when we are on the second iteration of for loop or while loop, whatever we are going to use. But I mean, if we are on the second element in the intervals array, this will start making sense. So what I wrote this here is that in the new interval, we are checking the last one. So whether my 5 is greater than or equals to this one. If this is the case, then we will say we are overlapping. This, because you might wonder that, okay, we are not even checking 2 and 3. Like, how is this gonna work? Like, what if, like, here it's, you are checking, you are ignoring this, right? What if this is 6? Still it's overlapping, right? Whether it's, even if it says this is 6, my 5 is still is greater than equals to 1. Or even if it's 2, right? Still my 5 is greater than equals to 2. Still, so every time this is overlapping, but it won't make sense here. Let's take another example. After we get, not another example, but the same example, but after first iteration. So we know that these two are overlapping. We will merge them. Okay, so it was 1 3, right, in the initial. Okay, so we will merge them, and after merging, what we will get is, we will get 1 and 5, right? After merging 1 3 and 2 5, we will get 1 and 5, correct? So in the next iteration, we have to check whether this 1 5 and what's the next is 6 9. Now we have to check whether these two are overlapping or not. And how we will check? We will check by, as I said, the last of the new interval, so which is this one, and first of the current. And you can see, is this greater? No, it's not. Okay, so we say that it's not overlapping. If I have used this previous logic of this one, then we have merged them and it will be 1 to 9. Okay, so that's why this logic is important in this case. Okay, so here we can see that it's not overlapping, so we will just move forward to the next iteration and we will add both of them, because since it's not overlapping, we have to add both of them into our final array. Okay, so let's see the code version step by step and let's see all the possibilities that we get. Okay, so I have just checked, taken the first example, but if we will see second example, then you can see that 1 2 is not overlapping with anything. Okay, so we have to just add 1 2 in the output and move forward. So firstly, we have to also check, right, whether there is an overlapping with 1 2 or not. Okay, so we will check that whether, so we have 3 cases. Okay, let me write those 3 cases in the code only. So 3 cases is like, let's say we have no overlap. Okay, then before the merging, so here first is there is no overlap, then here we have overlap, so we will merge all of them, because when we add 4 8 there is an overlap, so we will merge all of them. And then after all this merging is done and we are getting 3 10, there is no overlap between 310 and 1216. So we have three cases: before merging, and after merging, and while merging. So before merging, no overlap; after merging, no overlap; and while merging. So of course we are merging, so there is an overlap. So in short, we will have to consider three different cases. So let's have again our merged list, which will be our final output list. And here we will be using while loop. Okay, so why? Because we have to continue merging, right, until all the intervals are not merged. Okay, so and that's why while loop is preferable. Okay, because for loop has, so even this can be done in for loop, but it will be tricky. So let's focus with the while loop, and you will see why while loop, and it will take O of n. Okay, we will see that. So first is case number one, that there is no overlap. Okay, and that overlap we can check directly with our previous condition of previous problem. This, okay, this might sound a bit confusing, but it's super easy. That no overlapping before merging happens, or before merging intervals. So in this case, what you have to do, I have to first run the while loop. So my while I is less than n, and what you have to check? You have to check no overlapping condition. Okay, so what's the no overlapping condition? Here it's the same condition, that we will check the end. So we will check the end of current interval with the start of previous. So this is the same. So we will check the end of current if it is less than. So if my 3 here, let's check here because here it's satisfying. If my 2, right, is less than 4, yes, then there is no overlapping. So we will check with the starting. So if this is the case, no overlapping, so we have to simply add to our merged list what the very first, which is intervals, I guess, of I. Okay, and we have to just move ahead, just move on. Okay, so that's why this while loop is feasible here, that we have to just move on. Now case 2, where there is an overlapping. So as I said, we have seen this condition, what to do, but again we have to always put the sanity check of I, right? And now here is the condition of overlapping, which I already wrote, so I will write it again here, that my new interval last. So I'll show you that you can connect, that my new intervals last should be greater than or equals to the current start. Okay, current intervals but starting. Okay, then there is an overlap. So let me write that if this is the case, it's greater than or equals to the current. I'll also show you by debugging. Okay, I have the premium, so don't worry, and things will be more clear if this dry running on Blackboard and switching the tabs are not working for you. And so here now we have to merge. If this happens, then what we have to do, we have to merge, and of course after we merge, let's say first we will encounter 3 5 and 4 8, and we know that this new intervals 8, right, is greater than or equals to this 3. Okay, so clearly there is an overlap. So firstly what we will do, we will club 3 5 and 4 8 to 3 and 8, and then we will move on to 6 7, but now that will be compared with 3 and 8, correct? Because now 4 and 8 can't be 4 and 8 is being clubbed here. So every time we have to update our new interval now. If there is some merging happening, then this new interval needs to be updated. It's not like we are always considering new interval as 4, 8. Correct? So when there is some merging, we have to update our new interval. So of course that new interval will be, 0th will be, it's easy I guess, that we have to take minimum of what? Minimum of 3 and 4. So minimum of 3 is what? Whatever is the current intervals first. And 4 is what? Whatever is the new interval. And it's also first index. And for first new interval of 1, I'll just copy paste, and of course will be max. So what I'm saying is we have to take max of 5 and 8. So firstly I'll write 1, and also we have to take first index, and also we have to take max. That's important. Okay, so now my 3, 5 and 4, 8 is converted into 3, 8, and we move on to 6, 7. But now mind you, my new interval is 3, 8 because we updated it. Of course we have to move next. So let's move on. Correct? And we have to continue this process because now we know that 6, 7 and 3, 8. Okay, let me write that. That's 6, 7 and 3, 8. So this is my new interval. Okay. Sorry, I made a mistake. Yeah, no. My new interval is 3, 8. Sorry. My new interval is 3, 8. So this is my new interval. And this is my current interval where I am after my I is being incremented, interval of I. So what we have to check? We have to check whether this, the last element of this, which is this condition, that new interval of 1 is 8, whether 8 is greater than or equals to the start element of current, which is 6. Yes, right? So there is an overlap again. So this while loop will run continuously until this condition is not satisfied. Okay, so it will again run. We will again update our new interval. So what will happen is my new interval was 3, 8 and 6, 7. Now there is an intersection. So now it will become, we have to take minimum between 3 and 6, which will be 3, and maximum between 7 and 8, which will be 8. Okay. So now my new interval will become, will remain again 6 and 8, but, and we'll move on again. Now after this 3 and 8, we will move on again to 8, 10. So now we will check this 3 and 8 with 8 and 10. Again, this will be my new interval. So we will check whether 8 is greater than or equals to 8, which is, this is starting. Yes. So we can say that this is still overlapping, and we will club it to 310. Okay. After clubbing it to 310, this will be my new interval, which is 310. We will again check 310 with 12, 16. Now this condition is not satisfied, right? Because 8 is not greater than equals to, sorry, it was 10. Sorry, 10 is not greater than equals to 12, right? Next is 12, right? Yeah. So now this condition is not satisfied, and this while loop will not run again. Okay, until that this will continue, and we will move further. Okay, so let's see that in the code, that how we are gonna write. After this is being done, as I said, we have to append this 310. So after this while loop is being finished and everything is merged, we have to just use one append to append the merged interval. And what will be that merge interval? It will be again the new interval, which in this case of example 2 will be 310. Okay, so until now 1 2 was appended on this line, 310 is appended, still we are left with 1216. And now my I will point to 1216, okay, which is our case 3. As I said, we have to consider 3 cases that no overlapping, but after merged, okay, or after merging. Here what we have to check, here again the same condition, that we know that there is no overlapping, that's why we are here. So nothing to check more, just we have to check any elements that are left to be added which are not overlapping. So we are just adding the rest of the element, and in this case of example 2 it's 1216, which is what we are adding. We will just simply add that and we will move ahead, and we know that we are done with all the elements, so we will simply return merged. Things should be working. Let's see that. Oh, yes, it works. Let's submit. Perfect. So if things are still not clear, I'll debug it for you. So I hope the debugger will help us. It's a small example. We know that 1 3 and 6 9. Okay, so firstly, since they are overlapping, firstly we will check with 1 3 and 2 5. They are overlapping, right? So case 1 is not executed, and we will shift to case 2, and here we know that they are, so it will go inside. New interval 0 will be updated between minimum of 1 and 2, which is 1, and max will be updated to maximum of 3 and 5, which is 5. So now my new interval will be 1 and 5. You can see it was updated. Previously it was 2 5, now it's updated to 1 5, and we move ahead. So plus I plus or equals to 1. Now my I is 1. We can see that. Okay, so we know that now this condition is not satisfied because my n is 2, but this condition is not satisfied, that my 1 5, okay, new interval, right, is not greater than or equals to, because 5 is not greater than or equals to 6. So this condition is not satisfied, and we will just simply add our merged or the new interval to our merge list. So you can see this is being added now, and now this is not overlapping, so we have to just simply add 6 9. 6 9 is added. Now we increment I. Now I and n are equal, and our while condition will violate, so we will simply return. Okay, if you have to see exam case 2, I can also show you that. Let me close the debugger. Case 2, let's rerun the debugger with case 2. Sometimes debugger fails to connect, but I hope it will help me. So firstly, since we know that 1 2 and 4 8 no overlapping, so it will hit the case 1, go inside and simply append 1 2. So you can see 1 2 is being appended, and we move on to next iteration. Now our not overlapping condition is not satisfied, okay, because 3 5 and 4 8 are overlapping. So we will directly jump to case 2. You can see, jump to case 2. Now it's overlapping. So firstly 3 5 and 4 8 will be merged to 3 and 8. So you can see new intervals 0th will be 3, and 1 will be 8, which was same as previous, I guess. No, it was 4 8. Now it becomes 3 8, right, because of the minimum, and we move ahead. But still we are in the while loop. Why? Because my new interval, which is 3 8, it overlapping with 6 7, which is our current index. So we will again move ahead, and this will be 3 8. So now 6 7 and 3 8 are merged to 3 8. We will check again, 3 8 and 8 10, it's also overlapping, so we will merge to 3 10. You can see it's now 3 10. Now we will see 3 10 and 12 16, no overlap, so we will come out, and just when we come out, we will add whatever is being the merge interval of all these intervals. Okay, so we'll just add 310. So 310 is added, and now we move to 12 16, which is this one. So you can see, just we have to add 12 16, which is what is left. Now our counter is out of bound, so we will just hit the return. So I hope things were clear to you. And if we'll check, of course, space and time complexity, then you can see it's of n rather than of n log n. Yeah, and space, I don't think we are using any extra space, so it's of 1. So I hope things are clear, and keep practicing.